In this video, we'll talk about how to design and implement Web API in ASP.NET Core. Let's first see what a Web API looks like, and then we'll explain the details. Suppose we'll implement an employee management API consisting of three operations: get all employees, get an employee by ID, and change the supervisor of an employee. We'll start with the first one. As we mentioned before, a Web API controller should inherit from controller base instead of controller because Web API doesn't do views. All of our existing controllers inherit from controller class, so we'll create a new one. Visual Studio has a template for API controller, so we'll select that and we'll name our controller Web API controller. As we can see here, the API controller template has a route attribute and an API controller attribute here. When we specify a route attribute on a controller, it means the routes of all the actions in the controller will start with this. The default pattern generated by the controller template gives us API/controller name. Since I only have one API controller and I don't want the controller name in the URL, I'll get rid of this part. The API controller attribute does a few things which are not important for now. We'll come back to this later. Now let's implement our first API action. Just like a regular controller, we'll still need to use employee service to access database and do all that. So let me copy over this. And we still need the employee service, but we won't do authorization here. The constructor should be Web API controller, and we'll get rid of the injection of authorization service. Okay, so now we have access to employee service just like before, and we want to get all the employees. That's simple. We'll do employee get employees, and we'll simply return employee service get employees, and this is it. Nice and simple. And let's see. Oh, I forgot one thing. There's no route to this method, so we need to do a route, and we'll use the get method, and the route should be API/employees. Okay, so now it should work. And let's go to API employees, and it indeed works, and we get all the employees in a JSON array, and each employee is a JSON object inside the array. So this is what a web API looks like, which is really pretty simple. But what exactly is a web API? I think the best way to understand web API is to comparing it to what we call web applications. For web applications, the intended audience is human beings, which is why web applications generate HTML pages to be rendered by a browser so people can see them. Web API, on the other hand, is used by programs. As shown in this diagram, typically web APIs are used by mobile apps, desktop applications, and other web applications, both the traditional type, the traditional MVC applications, and then the so-called single-page applications, which are quite popular these days. Once we understand this, it's easy to understand why it's called API, because it's just like a library that provides a bunch of functions to other programs through an API. And more importantly, now we see why it returns JSON instead of a view, because JSON is a cross-platform data format that can be easily understood by programs written in different languages. As we just saw, implementing a web API is not difficult. In fact, it's easier than doing MVC because we don't even need to implement views. With that said, in order to design and implement web APIs properly, we need to know a little bit more about the background of web API. Web API has many other names. You'll probably have heard of some of them, like RESTful Web Services or REST API. REST API in particular is still very widely used today. So now we know why it's called API. What about web services and REST? Web service actually has a bit of history. It started with something called Remote Procedure Call, or RPC. Then came something called CORBA, which is basically cross-platform RPC. And then came web services, which are basically cross-platform RPC over HTTP. And then a new type of web services called RESTful web services came along, which are basically what we call web API today. Understanding the whole history of web service is not too important for the purpose of developing web API, so we'll skip the details today. If you are interested, you can check out my lecture on web services. Here are the links to the YouTube video and the link to the lecture notes. So we skipped over web service, but what about REST? Well, this one is kind of important for designing web API today. REST stands for Representational State Transfer. It's a term introduced by Roy Fielding, who is an influential figure in the web community. He was involved in the creation of many specifications related to the web. In his PhD dissertation, he studied network-based software architectures, and REST is the term he used to describe the common characteristics of scalable, maintainable, and efficient distributed software systems. According to Rolf Fielding, these systems share 5 common characteristics, plus an optional one, and these are known as the REST constraints. The system should have a client and server architecture. It should not maintain internal state because maintaining state is expensive and prevents scaling. It should support caching, of course, and the resources in the system should be uniformly accessible, like having URLs or URIs, and the system should have a layered or tiered structure. And optionally, it should support code on demand. Think of code on demand like something like JavaScript. You go to a web page, it automatically downloads some JavaScript, which will run inside your browser. If you think about it, the web is actually the largest REST system, and that's where REST API got its name. It basically tries to mimic how the web works, and that means use URLs to represent resources, use request methods to represent actions, and use response status codes for result statuses. And on top of this, do not use session because stateless is an important REST constraint. Once we understand where REST come from, it's easy to understand the conventions people use to design web API. For example, in terms of using URL to represent resources, we would use employees to represent all employees, employees/ID to represent an employee with a specific ID, ID/name to represent the name of the employee, and ID/supervisor to represent the supervisors of the employee, and so on and so forth. Representing a resource is only part of the story. We would need to say what we want to do with it, and this is where we use request method. If we want to retrieve the resource, we use get. If we want to create it, we use post. If we want to delete it, we use delete. And if we want to edit it, we use either put or patch, depending on whether we want to replace it completely or just change part of it. For example, here are 3 requests. Notice that they all have the same URL, /employees/1. But the get request would mean retrieving the employee object with ID 1, and the delete request would mean deleting it, and the patch request would mean changing the name of that employee to Jack. By the way, this is also why we have this for our get employees action. It uses the URL/API/employees to represent all the employees, and the get method to indicate that we want to retrieve all the employees instead of, for example, deleting it. And we also use response status code to indicate result status. For example, if the operation is successful, we return 200. If the resource is not found, we return 404. If some parameter is missing or invalid, we return 400, and so on and so forth. So now knowing what we know, let's implement the other 2 functions in our web API. Get employee by ID and change the supervisor by employee. Well, first, let's take a quick look at the documentation for the API controller attribute. So, as we can see here, it does a few things. It requires action methods in the controller to use attribute routing. It makes some assumptions about request binding. It automatically generates 400 response if binding error happens, and it also adds some additional description for error response. So all in all, nothing too significant, but it does make API development quite a bit easier, or quite a bit more convenient, let's put it that way. And speaking of attribute routing, Web API usually uses attribute routing because we usually need both URL and request method to determine what operation to perform. This is different from typical web application where the operation is expressed in the URL. For example, in a web application, if we want to add a new employee, we would want the URL would be something like employees at, but for API, the URL would be employees, while the operation is expressed in the request method using post. Okay, so now let's go ahead and implement the second operation, which is get employee by ID, and we'll use a get method, of course, and the URL representing the employee to be retrieved would be employee/ID, which makes sense. And let's return the employee object. And that will be as simple as get employee ID, something like this. So let's give it a try. Stop here and then rerun it. So we go to API employees 1, and we get John, and 2, we get Jen. Oh, by the way, it seems like we are getting 2 employees here, but it's actually 1. The reason we also get John is because John is the supervisor of Jen, so we are getting John as the supervisor property of Jen. So this is still 1 employee object. If we do 3, we get Tom, and Jen is Tom's supervisor, and so on. So far so good. However, if we try, for example, 0, doesn't let me to do 0. How about 11? I think there's something about the browser. Let me, instead of using browser, I'm going to use this tool called Postman, which is a commonly used development tool for developing web APIs. I actually want to talk about Postman when we get to the next example, but let's use this one for here. Okay, so here it shows clearly what's happening, and when I use a browser, when it gets 204 no content response, it just shows the previous page, which is kind of confusing. But here we can clearly see that if we do 1, we get John. If we do 2, we get Jen with John as the supervisor of Jen. But if we give it an ID which doesn't match any employee, we get nothing. And here it also shows that the response code is 204, no content. Now, it looks okay, except that I want to get a 404 or return a 404 response code instead of 204. 204 is still a 200 response code, meaning that it's still successful, but I want to use response code to indicate that the operation is not successful and the resource specified is not found. If we look at the code, we are only returning an employee object. How do we specify that if it's successful, this is a valid employee object, and if it's not successful, it's not just a null object. I want to say it's 404. Well, that brings me to this bullet point. So an action method in a web API controller can return an object directly. And if we do that, that means regardless of what that object is, the status code will always be 200 or in the range of 200. In other words, technically it always shows the method to be successful. If we don't want that, we can use a number of status code helper methods in the controller base class. In particular, we can do something like this. So instead of returning the object directly, we once again return an iAction result like regular controller. However, here we're doing something like this. We'll get the employee and then we'll check if the employee is null. If the employee is not null, we are going to return OK, meaning returning a OK status or 200 status with the employee object. Else, we are going to return not found. This allows us to return different status codes plus the actual object when the operation is successful. So let's try this again. And this time, let's try employees 0 or API employees 0. Okay, so this time the browser actually gets the for response with the error message. And if we do it here, we get the same thing. Notice that here the response code is no longer 204, it becomes 404. And if we give it a valid ID, still works like before. So this is an important technique when we develop web API actions in ASP.NET, know how to use the status code helper methods in the controller base. Now let's do the third one, change the supervisor of an employee. So changing a supervisor of an employee is really just changing the ID of the supervisor. So we'll implement it like this. We'll say, let's put a new supervisor ID there, and we'll need two IDs in URL. So this represents the employee, this represents the employee supervisor, and this represents the ID of the supervisor. And we'll say set supervisor. Now, when we use attribute routing, the action method name no longer matters because it's not corresponding to the URL anymore, so we can basically use any name. And here we'll get the two route parameters, employee ID and the supervisor ID. And then, just like before, we'll get the employee first. And if employee is not found or employee is null, we'll return not found. Otherwise, we'll say employee supervisor ID is a new supervisor ID, and then we do save changes. And then we return OK. So in this operation. If the operation is successful, we don't really need to return anything back. We just return OK status, and that's it. So here is employee ID. Okay, so let's give it a try. Stop and then start. By the way, anytime we change the C# code, we'll need to restart the application. Changing views, we don't need to. We just refresh the browser. Okay, so now I'm running this web API, and if I try it here, it won't do anything. I say employees, let's say change employee 3's supervisor to John, something like that. So we are going to get an error here. The reason we are going to get an error here is noticing that this action method requires a put request, and a browser, when we do it like this, will send a GET request. So this will not work with a browser. And this is actually the bullet point regarding Postman I was planning to talk about, and I talked about this earlier. So because browser is good for mainly sending out GET and POST requests, but web APIs requires typically many other request types. Some people develop this tool called Postman, which looks like this. And this is a good tool for testing web APIs because it can let us to easily choose a bunch of different HTTP request method types and so on. So instead of testing it in the browser, which doesn't quite work, let's do it here. So first of all, let's get the employee number 3. So employee number 3 is Tom, and Tom's current supervisor is Jane. So let's create a new request, and this request will be a put request here. And the URL of the request will be employee Tom and supervisor, and let's change it to John. We'll send this request, and we'll get a 200 OK response back, meaning that the operation is successful. And if we come back and run this one again, notice that now Tom's supervisor is changed to John. And if we try this again, changing it back to Jane, and try this again, notice that it changes back to Jane. Okay, so that's how we implement web API. By and large, it's not too difficult. As I said, it's actually easier than doing MVC because we just need M and C, no V. Now, let's look at one more thing. Swagger/open API support we get when we create a web API project in Visual Studio. So let's create that project first. So let me close this one, and let's create a new project. And this time we'll create a ASP.NET Core Web API project. And same deal as before, and let's skip HTTPS, enable Open API support. Okay, so this is important. This is the point we are showing this example, so have that one checked and then create. Okay, So if we look at the code, it's pretty simple. So there's a model class called weather forecast, which has a date, some temperature, and there's a weather forecast controller, which is a API controller with a route, and the actual method generates, I think, 5 forecasts by just generate some random temperatures. It's not a real weather forecast service, just a mock service with some randomly generated numbers. If we run it, it looks something like this. And actually, I want to show the API first. So the API is weather forecast, I think. Right. So it generates a bunch of random numbers, random forecast. So this is not important. What's important is this one. So this is the Swagger / Open API support that I mentioned. Open API is a standard that defines an interface to web APIs, which allows both humans and computers to discover and understand the capability of the API. And Swagger is a set of tools that work with the Open API specification. What we see here is known as the Swagger API. So what this one does is it shows the information about the web API. For example, it shows that this web API has a operation at the URL web forecast and taking GET request and no parameters. And it also shows the so-called schema or the model objects returned by this action. And in addition to showing the information about web API, it's even cooler is it allows us to test the API directly in the web UI instead of using additional tools like Postman. For example, to test this UI, I just need to click try it out and then execute, and it will show the request it sends out, and it will show the response, which is 5 objects in a JSON array, something like that. So this is very convenient when we develop web APIs. It automatically generates essentially documentation for us and for the people who want to use this API, plus the capability to test the API directly from a web UI. There are a number of Swagger / Open API implementations. The one used by default in a web API project is called Swashbuckle. If we look at the, let me stop it, and if we look at the NuGet package, we can see the dependency is called swashbuckle.asp.NET Core. This library is very easy to use. All we need to do is configure some middleware and service in startup. For example, there are 2 middleware, Swagger and Swagger UI, and there's one service called Swagger Gen, and that's about it. So the library takes care of basically everything else. If you have an existing project you want to add Swagger / Open API support, you can do it yourself without creating a web API project from scratch. Okay, so please check out Chapter 9 of the ASP.NET Core book. Take a look at the online documentation about Swagger / Open API support in ASP.NET Core. And if you are interested, check out my lecture on web services. This is the end of this video, and this video is actually the last one for this course. Hope you enjoyed the course and learned something. Bye-bye.